Okay, so we will be discussing unit testing and what unit testing is, and we'll be using the Google Test unit test framework for this assignment. We will be doing unit testing in the next project, so hopefully this will help. So to first install the Google Test framework, you can find it in your extensions and updates. This is Visual Studio 2017. You can find it going to the online tab and just searching Google Test. And you will want both the Google Test adapter and the test adapter for Google Test. The test adapter allows you to create a separate project that is just a test project. Once that's installed, you will go to New Project, Test under Visual C++, Google Test, OK. We already have, well, I will go ahead and create one to show you what it looks like. And it's not working. No, it is working. Okay. Okay, so this is what you will see when you first pull it up. You will have your test file, your header file, and your implementation file. So it's not much there, but we will talk about what each of these mean in a second. I have already created a very simple project with some simple mathematical things, and Judah will be talking about those.
All right, so first I'm going to go to the implementation and we can see what each of the functions do. We've just got a simple square root and an exponent, an absolute value, and a ceiling function. They each do their own respective things and then return it. And we have this all under a class where we've defined in this header file, and then this is the main test file. And so we've got the main, and you have to include this special line, and it allows the Google test to run, and then you just use this run function and it runs all of the tests that you've created. Up here you have your tests that you've created, and you can give it a name and a description here, and then inside these brackets is all of the tests that you run under that one name. Yeah, we've created this class that we defined in the header file, and then we gave it a name, and then you get to use your actual tests. So you have to type in this expect EQ, and then it takes two parameters. The first one is what you give it in, and then the second one is what it expects. So this first one, we gave it the method of the test case called square root, and we passed it in the value of 4, so it should just give the square root of 4, which is 2, and this should pass. And then it kind of goes on throughout all of these, and we can just run this and we can see what it looks like. All right, so here you can see that it ran and there was one error with the absolute value of -5, which is right here, and it says that absolute value of 5, which is 5, is equal to -5, which is what we put right here. And then it shows that the rest of the test passed. Now we can change this and have this expect a regular 5, so you think that it would actually get a 5, and then change the method up here to where the absolute value is actually a negative. And so we can see what that looks like. All right, and this is what it looks like, and I give you an error for 2 of them, which it says that this first argument is a -32, and it's expected to be a 32. And the same for the second one, it's a -5, which is expected to be a 5. So it says it failed, and there's just those 2 tests that failed.
So when you put them back to how they should be in the original file, just taking away the negative, this is what it looks like when they all pass. Yay! And the usefulness of unit testing is what we believe is you are able to safely test a project much more complicated than what we've created to, and it's one step further than debugging. So before it even gets to the debugging stage, you can test all of your code using these test cases instead of running a program and having it fail in any way that it could. And there you go.